Thank you. So welcome to our ARDC National Skills Forum for May 2025. My name is Meirian, and it's my pleasure to welcome you to our forum on finding the right tool, cloud computing versus HPC. This is a very popular topic, and so we're excited to get into it today. Womenjika, or welcome. I want to start by acknowledging the Wurundjeri Woiwurrung and Bunurong people, who are the traditional owners of the lands on which I work and live. I pay my respects to their elders, past and present, and the elders, Aboriginal elders of other communities joining us today. I'm really glad that we have this opportunity to meet online and come together from vast geographical and even time zones. So thank you for joining us. I'm really glad to see some familiar faces. So welcome to those of you who have come to our previous ARDC National Skills Forum series. And a very special welcome to everyone who's joining us today for their first forum. And hopefully I'll see you at future forums as well. The purpose of this forum series is to shine a spotlight on the skills that researchers need in order to engage with national research infrastructure and to participate in a national research data commons. So myself, along with the wonderful skilled workforce development team at ARDC, runs these sessions on a monthly basis to bridge the gap between our annual skills summits. We hope to create an open assembly of skills practitioners and to generate discussion on key topics of interest to the community. I'm pleased today to be joined by three excellent speakers, Sonia, Sarah, and Abdullah, who will be giving a short lightning talk each respectively. We will then provide an opportunity for questions and discussion. So if you think of any questions during those presentations, please post them in the Zoom chat and we'll attempt to address them at the end. So our topic for today is all about finding the right tool and understanding the primary differences between cloud computing and HPC. We'll attempt to answer some key questions, including how do they differ in terms of how research tasks are completed? How can researchers determine which platform best suits their computational needs? And what are the latest updates and innovations in cloud computing and HPC? So without further ado, it's my pleasure to introduce our first speaker, Sonia Ramza, who is the User Support Manager for the ARDC Nectar Research Cloud. And Sonia is here to tell you all about cloud computing.
Thank you, Meirian, and thank you for having me here today. So as Meirian mentioned, I'm going to give a very short overview of the cloud and hopefully enough to give you an understanding to get started, or at least understand how it may apply to your research. So just starting really generally, what is the cloud? So that is you as a researcher being able to access computing resources, whether it's something like a cloud computer with, let's say, something like a GPU or extra storage attached, accessing it via the internet on demand as you require it. Services can be sometimes managed. So whether a group has gone and pre-built a service for you to access and use, and you just have to log in and get started, or you may access those resources via self-service. So you access a dashboard or a portal, and then you can launch and build custom resource as you require it. So launching a cloud computer of the size of your choice, installing all the packages and software of your choice, and you can get going to use that cloud resource. Some examples, I'm certainly not enumerating all the possible examples out there, but just as a starting point, we've got things like the ARDC Nectar Research Cloud. there are also commercial offerings you may have heard of, like AWS, Google Cloud, Azure. There are even different offerings that are provided which are particular to a particular use case. So, for example, sensitive data use. I know QSIF has a product called Keypoint. So, lots of different options out there for researchers. And to that, the cost, in line with the diversity of choice, it does also depend on the service and what your institution offers. So some might be at a cost, some might be subsidised for researchers. Even like in Nectar's case, it's based on an allocation merit scheme, and depending on the kind of research you have. So there's a lot of different options and different availability. And on my next slide, we'll talk through some of the examples of things you may want to do with the cloud. So in looking at it in a technical perspective, you may need more computing power and high-end resources for your analysis. Your local or laptop computer provided by a uni just may not have the power to crunch the level or size of research data that you have available. You may want to share your computer with colleagues who are either working remotely, interstate, and want to be able to share the workflows that you've created in a reproducible fashion. You can share instances very easily, or cloud computers very easily, with colleagues. You may want to host a service such as a website or a database where fellow researchers or other users may want to interact with data that you've presented. Sometimes you also need a different operating system. So whether you're using a Mac and your research software uses Windows or Linux. And another one, especially this is a big one for researchers, which is wanting to launch long-running tasks without worrying about power outages or even just your computer going to sleep. Because it is quite common for security for computers to go into sleep mode and then your analysis stops. So that's something or another problem that the cloud can solve. And last but not least, you may just want to have administrator access to your system to be able to do things in a custom manner and fashion and install the packages you need without hesitation or concern. So these are just, I guess, in a technical view, some of the things you can do. But how does this apply to research? And what are some examples of this working out in the wild, as I like to say? So here I've got 3 examples. I guess all good things happen in threes. I'm a bit biased because these are applicable to Nectar. So I've seen these being completed and hosted on the Nectar Research Cloud. So as an example here, the first one, eReefs is a data visualization tool looking at climate data and its impact on the Great Barrier Reef. So that's a data portal that's hosted on the cloud. I know researchers in Tasmania were able to collaborate with government partners on completing bushfire data analysis. So that enabled them to make decisions and conclusions around how they should complete protection for national parks in Tasmania. And last but not least, a group of researchers also were able to analyze genomic data. So that's very hefty, large data sets, DNA analysis or RNA analysis, and were able to make conclusions around how they may be able to save a particular fish species. And they were all able to do that on the cloud and harness the computing power of the cloud. So these are just some examples. Of course, there are many more, and there are now research groups looking into how AI can be used in line with the power that the cloud provides. But hopefully this provides at least a gentle and beginning of an insight into how you may use the cloud for research.
Thank you very much, Sonia. Our next speaker is Dr. Sarah Beecroft, who is a life science application specialist at the Pawsey Supercomputing Research Centre. And Sarah will share an introduction to HPC.
Thanks, Meirian. And as Emily said in the chat, Kaya from Noongar country over in Perth. So on to the first slide. What is HPC? So I'll do a bit of compare and contrast to what we just learned about cloud. So HPC is a really enormous compute resource. It has thousands of nodes. It also would have CPU and GPU access. It has access to fast disk and a really large amount of RAM as well. So where it's really different to, I would say, cloud is that this one resource is shared across thousands of users. So you don't have sudo access. Even I don't have sudo access. It's like 3 people in the center that can do things with sudo, which I think is for the best. So it also comes with additional rules. Like anything, if you live in a share house, if you live in an apartment complex, you can't just do what you want and start drilling at 3 a.m. You have to respect your neighbors, right? And so it's kind of the same with HPC. But what it does give you is a really unmatched scale of compute. So you could do something that is just impossible to do with any other resource. Maybe you want to run something that takes up the entire supercomputer, thousands and thousands of cores at a time. You can do that on HPC. You could do something with it, like a huge amount of data parallelism. So if you want to assemble, thousands of genomes at once, you can use that kind of to scale outwards, right? So on the next slide, we'll see. Yeah, exactly. I would say the HP use cases are things that are too large for cloud. What I see is a lot of users start off with like their laptop or like their lab's local Linux box, particularly in biology. Someone somewhere has bought a Linux box and then they realize that they can't do everything on that anymore. They'll go to cloud, which is an incredible step up. And I use cloud a lot as well, actually, for doing things like building containers where you have sudo access. So it's very useful, and you will find people will use cloud and HPC a lot of the time. But for things that you just can't do any other way, you can have this parallelism of many small tasks, or you can have solving a really, really large problem. I had a great time looking for giant cake photos, and I just can't believe that she needs a shovel for this one. It's incredible. So when I say too large, it might be too large in the sense that you need a huge amount of cores. It might be too large in the sense that you need like a lot of GPU access, and that's really common now. We see for people doing things with like training large language models or doing a lot of inference, these AI machine learning type of things are really great for GPU. But also, particularly in the biological sciences, your data set might be too large. So if you have like 0.5 petabyte of data that you need to work on, it's really difficult to do things with that. And so you can do that on HPC because it has these really large scratch file systems. And so I guess what I'm saying is HPC isn't just a physicist doing really large scale simulations. It's anything that is too awkward to fit somewhere else. So on the next slide, we'll see some examples of some research happening on Pawsey. So the oceanomics team, supported by the Meirian Foundation, they have an incredibly ambitious project to assemble genomes of pretty much all marine species. So they are constantly hammering the system, trying to do these de novo assemblies, which is really exciting. Protein modeling is another big one, so that's quite GPU intensive and well suited for HPC. And some of the reference data sets and this type of thing could also be really large and awkward to move around. Another one is really high-res climate modeling. So particularly this group is doing large-scale simulations of the southwest of Western Australia. So the southwest has all of the touristy towns. It has these beautiful forests near Margaret River, and they're all at big risk because of climate change. And so having that really high resolution map is very important for Western Australia. Thanks.
Thank you, Sarah. And finally, to compare cloud computing and HPC, I'd like to introduce Dr. Abdullah Sheikh, who is the training manager at NCI.
Thank you, Meirian. Hi, everybody. Good afternoon. I am Abdullah Sheikh, and I look after training and skills development at NCI. I'd like to begin by acknowledging the country. So I'd like to also acknowledge and celebrate first Australians on whose traditional lands we meet and pay my respect to their elders past, present, and emerging. Next. In today's talk, I mainly cover two things. First is I'd like to do a brief but kind of a practical comparison of when to choose a HPC and when to choose a cloud. And then I try and compare head to head what are the difference between the research computing infrastructures available to the researchers in Australia, head to head comparison between HPC, commercial, and research cloud systems. Next. So in my talk, a disclaimer that what I'll be talking about is all non-exhaustive. I'll be touching on a few things, but there can be other things to consider when comparing HPC and cloud technologies and when choosing which technology or platform to use. So when we talk about HPC, as Sarah mentioned, it's more like a formal kind of a setting which basically around large computing infrastructure. And when multiple users are using a particular resource, there are some ground rules. So HPC environments are best suited for batch jobs, which is kind of like you submit your job and then you set that job and forget that job. And once you get your place in the queue, and when your job is executed, you get the output and get notified. If your workflows need high performance computing in terms of multiple nodes, if your code or algorithm in such a way that where it has to interact with multiple, it can be parallelized, and it has to interact with multiple nodes, then HPC is a good platform for you. When you have workloads that are tightly coupled, and when I say tightly coupled, I mean that when the processes need to communicate and synchronize with one another and quickly talk to multiple nodes during processing and during the analysis of algorithms. So that's called a tightly coupled workload, and HPC systems are really good at it. When you're when you have large memory requirements and especially when you need to access data and memory with low latency and high bandwidth, then that's also where HPC systems are useful. And as Sarah also referred to that image in her in her slide where there were multiple nodes. So all what HPC is about parallelization. It's a huge machine, high performance computing cluster, which has multiple nodes, multiple processors. And if your workflow is optimized for parallel processing, then HPC is well suited for your application. In contrast, sorry, can you go back? Right. Yep. In contrast, if we talk about cloud, cloud technology is really good if we have to scale up or scale down very quickly in terms of our workloads. As an example, if you need high memory and then low memory quickly, then cloud technologies are really good in scaling up and scaling down. Cloud technologies are really good if you have interactive jobs and analysis where you have to communicate with the systems or with your algorithms back and forth. In contrast, where HPC, I mentioned that it's set and forget kind of a setting where you submit your jobs as batch and then wait for your analysis to go in front, to come in front of the queue and get compute resources, process, and then you get the output. Cloud technologies are good for on-demand workflows as well, such as Jupyter notebooks, containers, and similar kind of things. And then like managed services, there are certain cloud managed services that might also be good for your use case. So cloud technologies would come handy there. Now, in my next slide, I will try and give a head-to-head comparison on the resources available in Australia and how are they differ from one another. So there are like two primary tier 1 facilities in Australia, NCI and Pawsey. And NCI supercomputer is called Gardi, Pawsey supercomputer is called Sotonix. But then there are other institutional high performance computers as well. In terms of research cloud, as Sonia mentioned, ARDC has Nectar Research Cloud Platform, NCI has a Meirian Cloud Platform, and then there are commercial cloud providers like AWS, Google, and Azure. The purpose of HPC is, of course, to run high performance compute intensive workloads. Cloud technologies, if I talk about research cloud specifically, they are there for flexible workloads for research and collaboration purposes. If you talk about commercial cloud providers, they are perhaps general purpose, scalable IT infrastructure. You pay them as you go, and then you can do heaps of things as per your requirements. In terms of performance, HPC have very high performance, optimized for compute. Performance can vary on cloud platforms based on the type of VM, the workload that you are choosing to run, and other factors. As far as hardware scalability is concerned, HPC systems have relatively low hardware scalability because the hardware is fixed. So if you want your hands on a latest GPU or a CPU, then that might not be available in the HPC cluster that you have access to. But if you have access to commercial cloud, they have really high they have really high hardware scalability because companies kind of like prefer and give them priority because of the commercialization. In terms of computer scalability, is relatively static as well in the HPC systems, but it's dynamic and relatively higher in the cloud atmosphere. As far as the cost model is concerned, the HPC systems that we have are mostly merit-based, and they can be institutional allocations as well. I understand that ARDC's Nectar is also merit-based, and it's free for eligible researchers. But commercial cloud providers go on pay-as-you-go model, and you have to be mindful if you have large data sets and if your jobs need to run for a longer period of time on commercial clouds, because there can be cost blowouts very easily. And as far as data handling is concerned, HPC systems have fast data handling capabilities. Data is locally stored. They have large stretch systems that can handle large amount of data. Research cloud can also handle fair amount of data, but it's volume constraint to an extent. Commercial cloud, sky's the limit. However, there can be substantial cost to transfer data and move it back and forth. Thank you.
Thank you very much to our wonderful speakers, Sonia, Sarah, and Abdullah, for sharing their expertise. So we'll now provide an opportunity for questions. If you do have a question, please either raise your hand on Zoom using the Zoom reactions, or you can type a question in the Zoom chat, and we'll try our best to answer as many questions as possible. I know that we've got a relatively large audience today, so we'll see how we go. I can see that there have been some discussion in the chat already. Comments relating to super user do, which is a command that allows a user to run a program with the privileges of another user, making them a super all-powerful user. That was shared by Kit. Thank you. We've got a question that's come in. What do you think the genuine costs of on-premise versus commercial cloud are?
When you say genuine costs, what do you mean by that? Like
genuine as in paying for the power, paying for the people, paying for every part of the stack.
Yeah, great question.
I can probably take this. So it's a difficult one to answer because
I do actually have some idea for that, which is that Pawsey calculated how much AWS would charge for the compute power that we give over a year, and it costs more than it, for 1 year running at full capacity, it would cost more than the entire center cost to build. Staff, power works, the whole capital refresh for 1 year. So it's actually, because they are making a profit on it and they pay their staff a lot more than anyone working for the government in this space gets paid. All these other costs, it's huge. But what you do get with places like AWS is, 5 nines uptime, where it's up 99.9999999% of the time. So you get what there's some pros and cons either way. I think there's definitely space for both, but the cost is definitely much higher overall with AWS or these types of providers than the government version.
Super, thank you.
Thank you, Sarah. Paul, did you want to add to that?
Yeah, thanks, Sarah. It was a good answer. And I think for HPC, it's probably even more problematic, but it's a tricky one to do because it's not an apples to apples comparison. But there have been a few analyses done between, say, the Nectar cloud and commercial cloud, and it's typically anything from a factor of 2 up to a factor of 10 that Nectar is cheaper to operate, depending on the type of thing you want to do and exactly what you're looking at. So, storage might be different than compute, might be different than GPUs, for example. But it's certainly fairly significant difference, partly because, as Sarah said, we don't offer, extremely high uptime. We don't offer 24/7 user support. We don't offer all the services that commercial cloud do, but we offer the basic things that researchers typically want at a much more cost-effective price.
Thank you, Paul. I can see there's a follow-up question directed at you, Sarah, in the chat regarding benchmark data for AWS versus Pawsey. I'll let you, if you'd like and are able, maybe you can respond to that directly in the chat, unless you'd like to say anything else verbally.
I would need to check if that's something we can share or not. I didn't do the analysis, the higher ups did, so it will be a question for them.
Thank you. I can also see a comment from Emily. If you don't want to have your name shouted out and you're typing a message in the chat, just let me know. Even cost for storage with AWS. I had a researcher who was paying $100 per month just for the data they had on AWS. So
yeah, I would have to say, I don't know about NCI, I'm sure they also have excellent options, but for the data storage that we have at Pawsey, it's like the world's largest Ceph storage system with S3 integration, but it's incredibly cheap because we basically designed it, installed it, and now run it ourselves. You just couldn't get that type of cost effectiveness any other way, as far as I understand. And the data egress costs from places like commercial cloud, it's a real stinger, I think. So yeah, there's also that type of thing. We find ways to make it cheaper because that's our remit, is to make things available.
Yes. Another comment, feel free to unmute if you'd like to read or comment on this, but I can see, I think there is also an economy of scale. If we have cloud for all Australian researchers, for example, Nectar, it will be cheaper per researcher than if a university offered it. I'm scrolling back up now to see some other questions, lots of comments coming through at the moment. Are these centrally managed by IT or hybrid distributed through the university?
Well, I'll jump in for Nectar. So Nectar is a federated cloud. So we do have a core cloud services team who manage the core infrastructure, but then we also have our nodes based at different university partners, so Monash, Melbourne, in QSIF, which represents a bunch of different Queensland-based members, as a couple of examples, and those groups manage their different node infrastructures, so their local infrastructure, but then we also have our cloud services team who manage the core infrastructure. But that's for Nectar itself. I couldn't comment on the other groups. Maybe Sarah, you want to talk about Pawsey's setup?
Yeah, so we are like a standalone unit, I guess. So we're not managed by the university IT or anything like that. Users can SSH in to our facility to use it when they need to use it. I think if you had like tier 2, like university-based clusters, then those might be integrated with university IT. But as far as I understand, for both Pawsey and NCI, we're our own thing. So you come to us, we don't really talk to the university IT.
It's a little different for NCI. So NCI works both ways. So NCI is a standalone independent facility, not managed by any university. But university partners are our stakeholders. So although our compute allocation happens via NCMAS, which is National Computation Merit Allocation Scheme, but on top of that, we also have collaborations with universities, and we give quota of our compute resources to universities. Having said this, everything is managed by NCI and located at NCI and NCI's facilities.
Thank you. I've got a really interesting question here. What are the carbon footprint comparisons for HPC versus cloud? Is one method more environmentally friendly?
I think it really depends on the technology that you're using. So it's not, as far as I understand, as simple as cloud versus HPC or something like that. It's more about, the specific methodology. So for example, when we went from our old system Magnus to Photonics, we invested a lot in GPUs, which actually gives you kind of more bang for your environmental buck. So we get a lot more compute power for less, actual power, right? So although the compute capacity increased like 15 times or something, the power consumption only went up by 1.5 times. So in that sense, that was a lot greener. So yeah, it really depends, I think. I don't think it's a simple question of one versus the other. It's like, how is it implemented?
As far as Gaudi is concerned, so we're based in Canberra, and I think Canberra is a carbon neutral city. So most of our electricity is coming through natural renewable resources, I should say. So I think as far as environmental footprint is concerned, as far as power is concerned, we are running primarily on renewable resources.
That's great. It's really exciting.
I can see a follow-up question asking whether HPC uses solar panels.
Yeah, Pawsey does have some solar panels. WA is a great place for solar, sunny a lot of the time. So we do have some, but not enough to offset the full use of the system. As SARA is our parent organisation, and one of their goals is to be like carbon neutral in the future. And so how we tackle that in WA, I think is a tricky one. But one of the things that we do have, which is good, so a lot of data centres, to cool their compute, they will evaporate water, which you just can't do in WA. It's very dry. Don't evaporate any water. So what we have instead is water coming up from the Mullaloo aquifer at like 20 degrees, goes up, does all the cooling, and then gets pumped back into the aquifer, maybe like 23 degrees, so a little bit warmer, but that's, according to the ecological assessments, that's fine. So that is something that we have been able to do, which is a bit unique. So yeah, again, it really depends on how you've implemented it. I feel like solar would be a great thing for us in WA though.
I just want to add that many HPC facilities globally, not just in Australia, also think of ways on how to recycle the heat that's coming out of the cluster and systems. So one thing that's very commonly happening is cooling the racks with water instead of cooling them with air and then recycling that water in multiple ways, like taking that hot water to heat the building as an example, or using that hot water for other multiple purposes. So yeah, these environmentally informed decisions are being taken at NCI, and I'm sure they are being taken at Pawsey as well.
Actually, a really interesting one is at Lumi. It's like the peak HPC system in Europe, but it's based in Finland in a freezing town called Kajaani. And so they take all of their excess hot water, and they use it to send it to the local town. And so they pump it into the footpaths to melt the snow. But apparently they didn't realize this, but when Lumi went down for maintenance for a couple of weeks, they got a call from the council in Kajaani being like, "Where's all the hot water? No one can take a hot shower. What are you doing?" And they hadn't realized that it was basically providing hot water for the whole town, which is a really great use case. I really applaud what Finland has done with that. But just hilarious that they didn't even realize.
Thank you. There's another comment regarding the footprint in terms of the supercomputer doesn't take up that much space in comparison to the space you'd need for solar panels to power a supercomputer. And you can normally only put solar panels on your own building or you'd be taking up more space. But wonderful story, Sarah, about what's happening in Finland. Thank you for sharing that. Another comment or question that I've seen a couple of times in the chat, is there any security consideration between HPC and research cloud, in brackets not commercial? And someone else has asked, is one option more secure for data than the other?
It's a tricky question. I would say it depends. It's not like HPC is not secure. But it is a shared system. So, for example, at Pawsey currently, we don't actually have a policy in place to accept personally identifiable data. So, for example, with the health department, we don't want patient names and addresses on our system. Don't put it on there, please, is kind of the policy. Because if something did go wrong, we come from this public research background where, the most sensitive thing is the radio astronomy data. And so moving into the health space is something we're doing, and some types of data we can accept. With cloud, again, it's not shared, but what are the security standards? It's a big question. Unless you have something that is specifically set up like QSIF's Keycloak, that's, they've done all the work to make that a place that you can specifically go for that type of problem. Between public research data and really, really personally identifiable data, it's a bit of a grey scale between what's acceptable and what's not. And you really need to know, I think, for your data, what restrictions do you have? Because it kind of is on a case-by-case basis largely.
Would Sonia or Abdullah like to respond regarding security on cloud computing and HPC as well?
I'd concur what Sarah said. It's such a wide question, and just like Pawsey, NCI is also not a facility to store personally identifiable data. Having said this, data that's coming in our facilities is secure, but it all depends on the security layers that your project has, and what are the underpinning guardrails that needs to be put in place for a secure project. Yeah, so I think that's a conversation that you probably need to have when you're thinking of considering using any of the facility, let alone cloud resources.
Just to add to that, for Nectar, we do have certain security safeguards in place as a baseline, things like using key pairs, no passwords, security groups, whatnot. But we do also have, similar to what Sarah just highlighted, the sensitive data guidelines in terms of the data that you're bringing to Nectar. So we recommend that data with very high levels of sensitivity, what we classify as whether it's an orange or a red. We can provide a support article which explains this a lot better than I can right now. But we do have, you know, data with high levels of sensitivity, recommendation to use other platforms which are set up to be at a high level of security, things like Keypoint for those purposes. But we do have, you know, security guidelines in place, which are, you know, with the responsibility of the user to also implement them and ensure that they are using Nectar within those security guidelines as well. Now,
Sorry, Sonia, you go.
Sorry, I saw Paul, I saw you unmute before. So was there anything that you wanted to add to that? Paul's a colleague of mine at ARDC.
I was going to essentially say the same thing, but it is worth noting that ARDC is working on developing cybersecurity certified node of the Nectar Research Cloud. So we're looking to do ISO or IRAP certification. So we are working on trying to improve the availability to use Nectar for sensitive data and secure research environments. Probably next year. But as Sonia says, at the moment there are guidelines on the Nectar user support site explaining what you should or shouldn't do on Nectar in terms of sensitive data. You should also talk to your institution to make sure they're okay with it. And as Sonia said, Keypoint that QCIF runs is specifically designed as a sensitive secure research environment.
I'm just going to add that there's a provision to have this trusted research environment if you need a highly secured interface for your data. And that's relatively easier to implement on cloud environment than on a HPC system. So yeah, that's something that you may also consider.
Thank you. We're still getting a lot of questions and discussion happening in the chat, which is wonderful to see. One question that I'd like to pull out is, are trainers here finding that their user groups are changing? Does this impact how you run training?
I mean, I think for Pawsey, we're getting a lot more. I mean, this is obviously I work in the life sciences, so I'm very biased, but I would say that we are getting a lot more of these, like, you know, not physicists, other types of domains. And so physicists have been doing computational physics or whatever, or applications of that for a long time. So they start, you know, in their undergrad, they're writing code in Fortran or whatever. Whereas biologists, they often start in the wet lab or they start out doing R or whatever. And then they realize, you know, things are scaled up and they need to learn HPC to address the size of their data. So I think we have changed a little bit how we address some of that training. So we have like some more bespoke kind of training for that audience now, largely written by me, because you just have to have different assumptions in how, you know, what do they know and what's their background and how do they learn and this type of thing. It's a little bit different, I think. So having something that's more suited to that community rather than assuming like, oh, well, you all did Fortran and compiled languages, you know, since you were 20. It's a different thing. So yeah, I guess that's my 2 cents. You got to be dynamic, right? Like the community will keep changing. You as a provider need to keep changing.
Somewhat related to that comment, of course, it always has to come up. AI is becoming increasingly popular. Could you please provide an overview of how well current HPC and cloud platforms support AI models?
Well, if you have GPUs, good for AI. I'd say is the really short answer.
Just to add to that, Nectar does have GPUs. Just a blameless promotion there.
Yeah.
Great.
And you can sudo as much as you want. I really do love that about cloud. Like, I can build containers, I can do Docker, I can do whatever I want. No one knows how to work for a queue. Like, it feels like a luxury sometimes to be in the cloud, I think. Just doing what you want. Like having your own house compared to living in an apartment.
Wonderful. So I think we've got time for one final question. And the one I've selected is, are there any online tools that can help me decide whether to use HPC or cloud resources for a research computation? I think that's a great one to finish on.
It's down at the moment, but we did actually have what resources right for me, like kind of self-guided quiz on the Pawsey website. I had to take it down so that we could update what we say about Nimbus versus Nectar, because we're getting a Nectar node and decommissioning our old cloud service Nimbus. But so that's like kind of useful, but otherwise, yeah, I don't know if there's like some other thing that's available. Do you guys have a feeling?
Have a really cheeky answer in saying, "Oh, should we ask AI?"
Yeah, that's
but
actually
in
a great
terms of,
answer.
I suppose, but we could, like, in terms of Nectar as well, because sometimes it's also these talks and stuff can help with like understanding what its capabilities are and then thinking about what you need to do with your research and then matching those up. So we do have an extensive knowledge base and tutorial site, which may at least give some guidance and going, okay, I can see what it's capable of. And that's lining up with what I'm aiming to achieve with my research. I will attempt to use that, but also in terms of tools, just harnessing things like our help desk and the different help desks that these services provide. So at least you can ask and say, I'm kind of thinking I need to do this. Can I do that? And the help desk should hopefully be able to answer your question.
Yeah, I totally agree. Like the help desk is there for a lot more than just, I forgot my password. They provide really expert advice, and if it's probably the same at NCI and at ARDC, but Pawsey, we have like a kind of first tier of support, and then if you have like a really knotty problem, it'll get escalated to like a domain expert in that thing. So I actually answer a lot of tickets because it's like, oh, this thing is working really weirdly, like what's going on? Like, all right, well, let's get into it and see what's happening. But also we can provide that type of like reflective advice of like, oh, well, you're not sure, like, what's the size of your problem? We can have a chat. Yeah, so I guess don't be afraid to reach out and, just echo what Sonia has already said.
All right, and I can see Sonia's just shared a link. We can also provide some links following this forum as well. So I'd like to thank our wonderful speakers again and ask for your feedback. So we really hope that you enjoyed today's forum and that you learnt something. We hope that we got to your questions. If not, follow up with us later. Please do take a couple of minutes to complete our feedback survey. It is very short, only a few questions. The link to the survey is in the Zoom chat now. So we'd love to hear your feedback on what you enjoyed in this session and how we can improve in the future. Your feedback also helps us identify relevant and engaging topics for upcoming sessions. So we look forward to hearing your suggestions and recommendations. Thank you. And we hope you'll return to join us for our next ARDC National Skills Forum. The topic for our next forum is self-service data skills training resources for researchers. What works? Please join us next month on Tuesday, the 17th of June for an engaging session exploring how to make online self-service training resources more effective and accessible. And the ARDC is excited to be delivering International Data Week 2025 on behalf of RDA, CoData and WDS. ARDC is inviting you to Brisbane, Australia from the 13th to the 16th of October this year. So save the date and start planning your visit. Finally, thank you very much for your time today. Again, very thankful to our wonderful speakers, Sonia, Sarah, and Abdullah. Thank you for taking your time to share your expertise And thank you to everyone joining us for all your wonderful questions and discussion. Please visit our website if you would like to learn more about what we do, and contact us if you have any questions. We are on social media, but the best way to keep up to date with everything in national research data management and software, including the latest news, resources, events, and jobs, is to subscribe to our newsletter. So a very special thank you once again to our wonderful speakers, and I wish you all a lovely day. Take care. Thank you.